Hello students, today we are going to start exercise 1.1. In last lecture we have completed our exercise 1.1. Today we are going to start 1.2. It depends on function. What is function? Function is a special type of relation. It means if somebody will give relation, we can see is it a function or not. There are some rules. Now we are going to start function. Let x and y are two non-empty set. For making a function, we want two non-empty set. One as domain and second is codomain. A function of mapping f from x into y written as f, you can call a function or you can say a mapping f such that x approaches to y is a rule by which each element x belongs to x is associated with the unique element y belongs to y. What is the meaning of this? F you will call a function if element of x, it will be connected with the unique element of y. Unique how? Like 1 is connected with y. Here 2 is image of 1, 2 is connected with 4, 4 is image of 2. The element of y which are connected with the elements of x, those are called image of x. Fine. 3 is connected with 6, this is called image of. You can see every element of x has a unique image in y, that is called function. For example, f of 1, that is 2. What is f of 2? That is 4. F of 3, 6. For every element there is a unique image. It means this is a function. And every element of x is called pre-image for the element of y. Like 1 is pre-image of 2, 2 is pre-image of 4 and 3 is pre-image of 6. This is domain and this is called codomain. The set formed by all the f images of the element x is called the range. For example, these elements, they are connected with the elements of x. These are the range. Fine. And it is denoted by f of x. F of x, which f of x you will take for, that will be equal to y, because function you will apply on the elements of x and you will get the value of y. Then y is equal to f of x. You can write it y also and you can write it f of x also. Here we are using two variables. One variable is x and one variable is y. What is variable x? Variable x is independent. Independent means we are starting with the value of x and y value is depend on the value of x. It means y is dependent and x is independent. Now range is subset of y. See, subset of y means what is y? Y is codomain. Range is subset of codomain. How you will write ordered pair? You will write like this, bracket x comma y, like this you will write. First your x will be related to the domain and y will relate with codomain, or you can write it x will remain same and y, like I have told you, y is equal to f of x. You can write like this. Fine. One more example I am telling you how you will get to know it is a function or not. See, we are having two set. One set you can say x, one set you can say y. In set x there are three elements a, b, c. In set y there are four elements 2, 3, 4, 5. A is connected with 2, b is connected with 3. But c is not connected. There is no image of c in set y. It means it is not a function. What is the definition of function? In definition of function, element of every element of x should be having a unique image in y, but c is not having any image in y. It means this is not a function. What you will write here, f is not a function as c belongs to x, does not have any image. One more example I am giving you. Set x, again element abc. Set y 2, 3, 4. A is having image 2 and y, b is having 3 and b is having one more image 4 and c is having image 4. If you write it, what is f of a? That is 2. F of b, that is 3. F of c, 4 and one more f of b, that is also 4. Now you can see the elements of domain are repeating. B is repeating 2 times. It means B is having 2 images 3 and 4, and according to the definition, for every element of x there should be a unique image in y. This is not a unique image. B is having 2 images 3 and 4. It means it is also not a function. How you will write? It is not a function. Here b belongs to x has 2 images. What are the 2 images? 3 and 4. It should be unique. I think it's understood. Now we are going to start some types of function. First function is 1 function. 1 function with name only, it's clear. 1 1 1 2 1. One value will take from x, one value y will give to us. It means image it will give. A function f such that x to y is said to be a 1 function if different element of x have different images in y, different element of set have different images in y. How? See, f such that x belongs to y is 1 How you will write it? Means what is the formula? How you will prove it? See, by elements easily we can say. First I am telling you by elements. If you will see, a is having image 1, B is having image 2, C is having image 3, and D is having image 4. Every element of X has a unique image in Y, means one-to-one relation. A is having only one image 1, B is having only one image 2. Every element is having unique image. This is called 1-1 function. How I will write it? What they want to say, if you are taking two functions are equal, f of x is f of y, both are equal, it means which values you are taking from the x, those will be equal. Like x will equal to y, in that case they will be equal. For example, if I am saying f of 1 value is 4 and f of 2 value is 8, when they both will be equal, when again I will write f of 1 is equal to equal, because here these are equal, they will be equal when value of y will be equal. This statement is if and only. If and only if means if this is there, then it will be there. If x is equal to y, then f of x is equal to f of y. If they are not equal, then function will be not equal. When you will do examples, then easily you will get to know what is this. 1-1 function is called injective function also. One more name is there for 1-1 function, that is injective function. What is that? Injective function. 1-1 function is called injective function. If for every value of x there is a unique value in y, that function is called 1-1. Fine. Opposite of 1-1 function is called many-one. Many-one means for one variable if there are two values in y, that is called many-one function. Fine. Onto. A function f such that x approaches to y is said to be an onto function if every element of y belongs to y has at least one pre-image x belongs to x. Onto is called surjective function. What is the thing? In onto function you have to check y. You will check the elements of y. Is every element is having pre-image in x? 1 is having A, 2 is having B, 3 is having C and D. 2 are there, but at least 1 is there with every element. Every element is of y is having pre-image in x. It means this function is onto, and onto function is called surjective function also. How you will write? Here 3 has two pre-images, C and D, but it's not matter. F says that x belongs to y. F of x is equal to y. This is the condition for onto. F of x is equal to y, where x belongs to x, set x, and what is y? Y belongs to y. For 1-1 function you have to check 1-1 image. For onto function you have to check the elements of y. Is every element of y is having pre-image in x? That function will be onto. If any element is left, for example I will write here 4. Now 4 is not having any pre-image in x, it means it will be not onto function. Understood? Now next, when any function is 1-1 and onto both, that function is called bijective. If any function is 1-1 and onto both, that function is called bijective. 1-1 function is called injective also, onto surjective, and both, that is called bijective. Now start with question number 1, exercise 1.2. Exercise 1.2, question number 1. You can see in your book. Question number 1, show that the function r star to r star defined by f of x. Function is which type of function? 1 by x. We have to show it is 1-1 also and it is 1-2 also, where r star is the set of non-zero real numbers. What is the meaning of non-zero real numbers? We know in real numbers negative numbers are also there, positive are also there, and 0 is also included. But what they said, it's non-zero real number, it means now 0 is not included. After that, after proving it 1-1 and onto, what we have to do is the result true if the domain r star is replaced by n. What they are doing, after proving 1-1 and onto, they are changing the domain. In place of r star, they are taking n, and codomain it's same, it's r star only. Now first we will take the function r star from r star, where r is non-zero real number, and what is our function? Our function is 1 by x. First we will write function 1 by x. What is domain? How you will write? This is r star from r star. R star, this is our domain. From here we will take variable x. R star, this is codomain. Codomain is also r star. See, in real number, plus, minus value, root, every type of values are there. Only 0 is not there because it is non-zero real number. This they have mentioned. Fine. Non-zero real numbers. Same in y. If we will put f of, if I am putting 1 by 1, that is 1. If I am putting minus 1 by minus 1, that is minus 1. If I will put 2, that will come 1 by 2. If I will put minus 2, 1 by minus 2, minus 1 by 2. If I will put root 2,
f of root 2, 1 by root 2. It means for every element of x, there will be a unique image in y. It means this function is 1, 1. This function is 1, 1. You can write this function is 1, 1, but there are how you have to write. First you will write the function. What is function? F of x is equal to 1 by x. Like we have done in definition, for the function you have to take f of x is equal to y. Here we will take f of x1. x1 means in place of x you will put x1, then it will be 1 by x1. Again in place of x you will put x2. x2, f of x2, that will be 1 by x2. Now if means like it's true, f of x1 is equal to f of x2. F of x1 means, what is the value of f of x1? 1 by x1. What is the value of f of x2? 1 by x2. Yeah, if functions are equal, then its pre-image is also equal. Thus function is 1, 1, as there is only one image for every domain. Fine. Now we have to take onto. For proving onto, first you will start with the function. What is the function? F of x is equal to 1 by x. And what is f of x? F of x value is y. Here we have to find out the value of x. By cross multiplication, y will go in division and x will go up. What is x now? 1 by y. Now put the value of 1 by y, x, 1 by y in f of x. 1 by, what is the value of x? 1 by y. Reciprocal of y will come, y will go up. See, we have started with f of x, now we came on y. It means f of x is equal to y, then your function is onto. What was the condition for onto? Onto condition was f of x is equal to y. What was the condition for 1, 1? F of x is equal to f of y. Here we have to f of x1 is equal to f of x2. That was 1, 1. Now we are taking 1 to onto f of x, we have to prove equal to y. We will start with f of x. What is the value of f of x? 1 by x. From here we will take out the value of x. What is the value of x? 1 by y. That we will put again in the given function, and it will come equal to y. It means this function is the onto function. And every element of y is having pre-image in x. It means thus f of x is onto, as well element of codomain become range. Our full codomain is became range because every element of codomain is having pre-image in x. I think it's clear. How you will write it? You can write each and everything in your words. It will be clear. Fine. Now, what was our question? In question, they are saying after proving it, what you will do? You will change the domain. R star you will replace with n, and codomain will remain same. Now, our function is from n to r star. And in n, our natural numbers are starting from 1 to 3. And r star, in r star, there can be any type of number. Rational also, irrational also, anything. But it's non-zero. 0 will not be there. If you will see, if I will put 1, what will be the value? 1 by 1, 1. If I will put 2, what will be the value? 1 by 2. If I will put 3, what will be the value? 1 by 3. For every element of domain, there will be an image in codomain. But every element of codomain will not get pre-image in the domain. It means this function is 1, 1. Fine. But this function is not onto. Why? Because put any value here, answer cannot be 2. Put any value, put any natural number here, answer cannot be 3. What about these numbers? These numbers will not get any pre-image. It means this function is 1, 1 because every element of domain is getting image, but every element of codomain is not getting pre-image. This function is 1, 1. This function is still 1, 1 as every image has a unique pre-image. Every domain has unique range, but this function is not onto because our full codomain is not become a range. Range is a part of codomain. Understood? Now question number 2, our function is from natural number to natural number, and it is given by f of x is equal to x square. F of x. First we will make our domain is natural number. Natural numbers are starting from 1, 1, 2, 3, 4. Again our codomain, that is also an 1, 2, 3, 4. What is f of x? X square. I will start with 1. If I will put 1, what will come? 1 square? 1. If I will put 2, 2 square? 4. If I will put 3, 3 square? 9. Every element of domain will get unique image in codomain. Yeah, image will not repeat. Yeah, 5, then it will come 25, 6, then it will come 36. Every element will get image in codomain. It means this function is 1, 1. But if you will see, every element of codomain will not get pre-image in the domain. It means this function is not onto. This function is not onto. How you will write it? You will write for every domain there is a unique image or range. This function is 1 1. But all the elements of codomain does not become range. Range is a subset of codomain here. Because it is 1 1, you have to mention it how it is 1 1. Like I have told you, first you will write the function f of x is equal to x square. Now you will write f of x1 is equal to f of x2. For this you want x1, f of x1. In place of x, put x1, x1 square. In place of x, put x2, x2 square. Now you will take both are equal, write it f of x1 is equal to f of x2. What is the value of f of x1? x1 square. What is the value of f of x2? x2 square. Take square root on both sides. Here we are not going to cut the square. We are taking square root on both sides. We will take square root on both sides only positive. But when you are taking square root of any number, then you are getting two values. One is in plus and one is in minus. But here we will take only positive value because we are working on natural number. Fine. And natural numbers are positive in sign. Then x1 is equal to x2. So this function is 1 1. 1 1 it is, that's why we have proved it. It is not onto, no need to prove anything. You will write this function is not onto because all the elements in codomain does not become range. Now second part of second question, our function z approaches to z. First it was from natural number to natural number, now it's from integer to integer. Again in integer, negative, positive, 0, all values are there. What is our function? F of x is equal to x square. Now f of, when you in place of x you will put 1, 1 square 1. When you will put minus 1 square, that is also 1. If you will put 2, 2 square, that is 4. If you will put minus 2, that is also 4. You can see easily, for 1 also there is a image 1. For minus 1 also there is a image 1. For two elements there is a same image. There is no unique image. It means this is not 1 1. This is many 1. This is many 1. If you will see from here, 1 is having two pre-image, 1 and minus 1, many 1. This is many 1 function. Fine, and this is not onto also. Why? Well, you can put any value from the integers. You will get answer in the positive number because it's x square. Put any value. When you will do the square of that number, you will get the positive value. What about negative numbers? Negative numbers are also there in integers. You will not get any pre-image of negative numbers. It means your function is not onto. You can write it here also. Range is a subset of codomain. It's not completely equal. Every element of codomain does not become element of range. This given function is not onto. This is not 1 1 also. This is not onto also. Now we are going to do our part number 3 of question number 2. Now our function is real number to real number. Again in real number, positive, negative, rational, irrational, all type of numbers are there. How your function is given? Your function is f of x is equal to x square. Again in place of x, if you will put 1, 1 square 1. If you will put minus 1, that also 1 square 1. If you will put 2, 2 square 4. Again minus 2 square is also 4. Again for same element, there for different elements there is the same image in codomain. Like for 1 also 1, for minus 1 also 1. Here only easily you can say this function is not 1 1, it's many 1. And this is not onto also. But about negative numbers in codomain, negative numbers will not get any pre-image in domain. It means it's not onto. Fine. Now question number 3. First, starting with question number 3, I want to tell you one thing. Here they are talking about greatest integer function. What is greatest integer function? When, like this is the variable x, when you are using this type of bracket, this type of function is called greatest integer function. What is the meaning of this function? Name is greatest integer, but values are lowest. For example, when you will put 1 3 2 in this function, if you will see 1 3 2, it's nearby 1, yeah, you can say answer is 1. But you will take 1.99, in that case also it's nearby 2, but because of these bracket, because this is greatest integer function, your value will be again 1, lowest value. Name is greatest integer function, but value will be lowest. Fine. Now our function is r from r, real number to real numbers. It means any type of number. Decimal numbers are also there, rational numbers are also there. Here mostly we will use decimal number for proving this. Why? Because in greatest integer function we have to want integers, full integers, means values will come in integers. If you will put decimal also, then also value will come integers. Yes. domain real number, range real number. If you are putting 0, f of 0, that is 0. But in a place of function x, if you will put 1.32 here, then 1.32 you will take 1. If you will put 1.99, then also value will come 1. If you will put 2.01, 2.01 it's nearby 2, value will come 2. If you will put 2.99, in that case also value will come 2. Fine, this is the function of a greatest integer function. Now you can see for two elements of the domain, there is only one image in codomain. It means this function is not 1 1, this function is many 1. Same, if you will see here 0, 1, 2, 3, these values can come. But what about rational numbers? They will not get any pre-image. For example, if I will take here 1 by 2, or if I will take 0.23, they will not get pre-image in the domain. It means this function is not 1 1 and this function is not onto also. Fine. Now start with the question number 2. Our function is from R to R and our function is modulus function. What is modulus function? Which function is changing negative value also in positive value. R to R, in R we will take 0, 1, minus 1, 2. Rational numbers also you can take because this is real number. Our codomain is also R. If you will put f of 0, mod of 0, that is 0. If you will put 1, mod of 1, that is 1. If you will put minus 1, mod of minus 1, that is also 1. You can see for 1 also image is 1, for minus 1 also image is 1. For two elements there is the same image. It means this function is not 1 1, this is many 1. Same, this is not onto also, because for all the elements of codomain there is no pre-image. You can take minus, put any value. What about minus 2, minus 3? Negative numbers will not get pre-image in the domain because this is modulus function. So this is not 1 1, this is not onto. Now next function, you have to see this. In exam directly they can give a signum function. What is signum function? Signum function is like this. This is from R to R. F of x, for every value which is greater than 0, x is greater than 0, for them value is 1. If x is equal to 0, that is 2, value is 2. If x value is less than 0, for them value is minus 1. Put any value. If you will put in place of x 2, then also your f of x, or you can say your y, will come 2. If x value you are putting 0, that is 0. If you will put minus 2, then also value is minus 1. Minus 3, then also minus 1. Easily you can say this is called signum function. This is called, already they have given, but you should know what is signum function. Fine. Now easily you can say there are only 3 values which are 1, minus 1, 0. If your x value, if you are putting 1.7, it's positive, then what is the value? 1. If you will put 100, then also value is 1. If you will put 0, that is 0. If you will put minus 3.55, because it's less than 0, then value is minus 1. If you are putting minus 2, according to the condition, only 3 values are there. 1, 0 and minus 1. It means by above calculation, we can say that the signum function is many 1 function. It's not 1 1, it's not onto, as only the elements 1, 0, minus 1 from the codomain became part of the range. Yeah, only 3 elements, 1, 0, minus 1. Only these are the parts of a range. So this function is not onto. Now your question number 6. Our set A is given 1, 2, 3, set B is given 4, 5, 6, 7, and already function is given 1, 4, 2, 5, 3, 6. First you will write domain, then you will write codomain. What elements are there in domain? How you will write it? You will write like this: function A approaches to B. A 1, 2, 3, set B 4, 5, 6, 7. 1 image is 4, 2 images 5, 3 images 6. They are asking prove that this function is 1 1. You can see each and every element of domain is having unique image in codomain. 1 is having image 4, 2 is having 5, 3 is having 6. As every domain has unique range, this function is 1 1. If you will say check it, is it onto? No, because 7 is not having pre-image in the domain. It means this is not onto. Here they are asking only 1 1. Like this, our question number 6 is over. In next lecture we will start with question number 7 and we will complete this exercise.